Okay guys, welcome back. So today I'm going to talk about conduction. Conduction is a somewhat complex topic to some students. So actually it's just a simple example, right? Just a simple theory, but conduction doesn't seem to be. But as the request of students go up with the request that you should add a video on conduction. Now I'm introducing the concept of conduction to this series of lectures on heat and physics. So what is meant by conduction and what is the equation of conduction? So conduction seems to be very easy concept, but at the request of students go high to insert a video on conduction, I am inserting that lecture here. Alright, so what is conduction? Conduction, right? Conduction. So conduction is a simple process. If I have some rod here, a metal rod, a metal or some, for conduction to happen, it should be some metal or something that is a heat conductor, not a heat insulator. It should be a heat conductor. So that's the first requirement for conduction to occur, right? So this is conduction. So if I put some heat energy, if I put a candle or something like that, right, a candle or something like that, some flame here. So this will provide some heat energy to this rod. Now what actually happens is there are mobile electrons on this rod, assuming this is a steel rod or something like that. What it actually happens is that these electrons tend to increase their kinetic energy. Now they already have some vibration inside this rod, so the total vibration is approximately some value, but we can feel that. So what actually happens is, now they will increase their vibration, they will increase their kinetic energy, and they will increase their vibration velocities. So when they increase their vibration velocities, they will increase their vibration speeds and the distances they travel. So the heat gets transferred along this rod. Now if we are taking this electron, the vibration velocity of the vibration increases. So energy from this electron to this electron, you will pass the energy from here to here when this electron hits this electron. When this electron hits this electron, the energy gets passed from this electron to this one. So likewise, the energy is transformed like this, from electron to electron throughout the rod, and you will feel some energy at the other end, right? But what actually happens is that if this is not insulated, not the rod, right? Not the rod is a conductor, but if this system is not insulated, what actually happens is that some energy is dissipated to the environment, right? Some energy is dissipated because the total energy is not used to increase the kinetic energy of the vibration of the electrons. So the total energy, this is first electron got an energy of 100 joules. The next electron, we can't say that there's a possibility of getting 100 joules if this rod is not insulated, if this rod is in open air, right? So if this is not if this is in open air, if this is not insulated, there will be some dissipation of heat. But for the simple calculation, what we do is we take this rod as an insulated rod. So this is a condition like this. You take a rod, right? You insulate it. Insulate it means you are covering so that the heat won't dissipate to the external environment. Right? You are insulating. So you provide some heat here. You say you put some heat 500 joules. So since some energy is since any energy is not dissipated here, the total energy at the other end will also be 500 joules. But there will be a temperature difference. Now if the initial temperature when the heat was received here is 70 degrees Celsius, the temperature here will not be 70 degrees Celsius because some energy is still present here. This is not like just moving a vehicle from A to B. Now if your vehicle is moving from A to B, the velocity of the vehicle at A, say there's a velocity of 10 meters per second, at B if it is 60 meters per second, that doesn't mean that the velocity is still remaining at A. The object has already moved out of A, right? But in this rod, now this is a composite system, right? A composite system. This part of the string, this part of the rod has not moved to this one, right? This is not like movement of a vehicle in some on some road, or the movement of ship or a plane or something like the movement of some object in some direction. This is not like that. Now, this is a fixed one. This is a fixed one. When the energy is received at this end also, the other end is still there. So what it actually means is that some energy is still remaining. That although some energy is not dissipated to the environment, some energy is still remaining at this end. So if the initial temperature at this end is 70 degrees Celsius, we can't expect the same temperature at the other end. It will be less than that. Right? I will take it as some 40 degrees Celsius. And this rod has some length L. And an area of A, right? So if I put 500, if I give 500 joules within 1 second, we can estimate a rate at which the energy is given. So this is 500 joules per second or 500 watts. So that is the rate of change of energy, right? So this is the rate. So if I take the rate now, for the calculations I have been using so far, I have been using the energy in the form of, in the notation of Q. So Q equals 500 joules, T equals 1 second, so the rate of change is Q by T. Q by T, if I take Q by T to be a constant, if I put constant energy, experimental data has shown that this energy is proportional to the temperature difference, directly proportional to the area, and inversely proportional to the length of the rod. Now length of the rod means, if you are taking, now this is between A and say this is the point A here, point P here and point Q here. So that doesn't mean that you have to take the whole length of the rod. If you are taking a point somewhere R in the middle of the rod or somewhere 1/4 of the rod length. So L means the temperature we have to take. If you are taking the if you are putting the equation between P and R, you have to take the temperature difference between P and R, and assuming that this is a uniform rod, its area will be a constant. So area will not change if you are putting from P to R or from P to Q. And if you are putting from P to R, you have to calculate the distance between P to R and then find the value of L, right? So we can write from dimension analysis, Q by T is, if one quantity is directly proportional to one quantity, this is inversely proportional, right? It's inversely proportional to L. Q by T is inversely proportional to L, right? Or directly proportional to 1 upon L. So you can write from dimension analysis that if A is directly proportional to B, A is directly proportional to C, and A is directly proportional to D, we can write A is directly proportional to B times C times D. So we will use the same concept here. We can say Q by T is directly proportional to A times delta D times 1 upon L, right? A times delta T times 1 upon L, that is from the dimension analysis. So if this is so, we can take, now these are directly proportional, so we can remove this directly proportional by equating it with a constant. So Q by T is equal to K times A times delta D, I will take this 1 upon L divided by A. So this is the general equation that we are using in conduction. So that's simple. This is the general equation we are using in conduction. So Q by T is the rate of change, rate at which the energy is provided. So say after 2 seconds I have provided an energy of 500 joules. So Q by T will be equal to 500 by 2, which is 250. It is also equal to the power, right? Power. So K is a constant. K is called the conduction constant, or the thermal constant, right? The value of K. So K is a constant, A is a constant. You can K actually differs for say you are giving the same Q by T value here. You are taking the Q here, same cross section of, if you are taking two rods like this, right? Two rods like this. If you put the same value of Q, if you put the same energy within the same time, Q by T is constant for what these rods. L is a constant. If you take L is a constant and A is a constant, but these two rods are made of different materials, K changes. So K1 is here and K2 I'll take here. So the temperature difference here will be delta T1 and delta T2 will not be equal to this equation. Q by T is a constant, means K times A times delta T by L is a constant. So A and L is a constant already. So K times delta T is a constant. That means K1 times delta T1 will be equal to K2 times delta T2. So that will be a very simple, just an equation, right? So that is the theory of conduction. So in the next video I will use a simple example in elaborating the principle of conduction. See you then.